Okay, now on to the lesson for 5-2. This is fractions to decimals and decimals back to fractions. Things like 3/4 you know is 0.75. We're going to talk about how to go back and forth, so how to turn 3/4 into 0.75 or how to turn 0.75 into 3/4. We're also going to talk about putting them in order, and again, this whole thing is really about that lovely term we discussed a little bit ago that is rational numbers. So that's kind of the whole point in this topic. So, all right, starting on the next slide. Okay, first part of this is fractions into decimals. So fraction, turn them into decimals. So we'll start with the example I just did. We had 3/4, and we want to turn that into a decimal. So remember that means that the top number, 3, is divided by 4. So that means we have 3 on the inside divided by 4. Now we know 4 does not go into 3 nicely. So we're going to put a 0 on there. 3, and bring your decimal up. 4 does go into 30 though. It goes in there 7 times. So 7 times 4 is 28. Subtract, right? Long division. I know you love it. 30 minus 28 is 2. Got to give another 0. Bring it down. 4 goes into 20 5 times exactly. And I'm done. So my answer then, 3/4 is 0.75 as a decimal. Next example, we're going to use a mixed number, 1 7/8. Let's do this the easy way. We'll start out. It's going to be 1 point something, right? Because 1 is a decimal is 1. So it's with that 7/8 I have to be worried about. So again, 7 divided by 8. 8 does not go into 7, so we need a decimal there and add a 0. But 8 does go into 70. It goes in there exactly. Can you guess? Can you guess? 8 times. 8 times 8 is 64. So do a little borrowing, right? So 7, 6, 10, bring down what is 6, right? And need another 0. 8 goes into 60. You guess? How about 7 times? 8 times 7 is 56. You got a 4. I'm running out of room here. You've got a 4. And so let's move that up a little bit so you can see it better. I'm going to go like this. There we go. And I can slide back when we're ready for more. Anyway, so we've got going into, oh, what are we at? 4. Okay, yeah. So bring down a 0. 8 goes into 45 times. And exactly, right? So I get 0. So 0.875 is what we end up with for, there we go. That's great. We slide back out of the way. So it's 1.875. So again, the 1 just transfers over, right? And then we have to divide the 7/8 out. That's all this fun stuff here. We get 0.875. There you go. Okay, so sometimes it doesn't come out super nice. Well, it does kind of come out nice, but 2/3. This isn't going to end. You probably know that already, though. So it's like we did before. We have 2 divided by 3. Add a 0 there. And 3 does not go into 2, but 3 goes into 20. How many times 3 go into 20? 3 times 6 is 18. Subtract and get a 2. Give another 0. Bring it down. 3 goes into 20. 6 times. That's 18. Bring down a 2. Are you seeing the pattern here? Right? It's never going to end. On forever. I'm going to put the 6 on there for good luck. Going to go on forever and ever. So technically 2/3 is 0.6 repeating. So just a division problem that goes on forever and ever and ever. Okay, one more that's going to repeat. This one is 15 elevenths. And yeah, I know it's going to repeat. So that number, by the way, 15 elevenths, is actually what? It's an improper fraction, right? So if you wanted to, you could make that into 1 and what, 4 elevenths, if you really wanted to. Let's say you didn't remember that. Let's say you did not remember that. So you could start out with 15 divided by 11. Don't forget your decimal point because you're going to need it. 11 does go into 15. It goes in there one time. 11, right? We've got a 15 minus 11 is 4. Give it a 0, bring it down. And 11 goes into 43 times. And so that's 33. So 3 times 11 is 33. 40 minus 33 is 7. And then we'll get another 0. And 70. 11 goes into 76 times. 6 times 11 is 66. And you subtract and you get a 4. That's a 4, I promise. Get a 0, bring it down. 11 goes into 43 times. And here we're going to move that just a second so we get a little more room again on that. There we go. And move it over here. There we go, that's better. And we're going to keep going with this, right? So 33 and 7 and bring down a 0. And it goes into 76 times. Oh, look, we're starting to see a pattern, right? It's going to go on and on and on. It's never going to stop. So 1.36 repeating. Again, what that really means is 1.36, 36, 36, 36, forever and ever. Okay, so this time we're going to do the reverse. We're going to go decimal back to fraction. And I know you did learn this stuff last year, but I think it's probably a good idea for us to review that. The first example I want to do, actually, so this one I guess I want to say this is my I think one of the easiest things we're going to do. Let me kind of give you steps for it. Step 1, right? We're going to write it like you say it. Write it like you say it. So that means, so I don't say 0.2, right? I don't say 0.2. So if I have this as 0.2, I say 2/10. 2/10. Right? Second step would be to reduce. Okay, reduce, because it's going to be a fraction. So 2/10, right? So that'd be 2/10. So 2/10, reduce that, we all know is 1/5. So decimal to fraction is write it like you say it, and then just reduce. So let's do a couple of those. First one of those is going to be, I just kind of talked about it, 1.2. So you say 1 and 2/10, right? 1 and 2/10. Still got to reduce that fraction part right there. So what that really is 1 and 1/5. And how do you reduce this? Right? You know, you divide all kinds of ways you guys have learned, I'm sure, right? Divide by 2, divide by 2, right? So we end up with 1/5 on that part. Otherwise, we can put it in the cake. That's another way, right? So we put 2 and 10 into the cake, and a 2 comes out. We get 1 and 5. Oh, look there, 1/5. That's why I love the cake method. Let's do another one here on the next slide. So again, our steps were to convert from decimal to fraction, to write it like you say. You don't say 1.75. I mean, a lot of you say that, but it's really 1 and 75 hundredths. So it's 1 and 75 hundredths. That I know you can reduce. So that's going to be 1 and something, right? Now, again, maybe you can go by 25s, divide them out by 5s. We can also use that cake method. 75 and 100 go into the cake together. Does that sound funny? We start with a, well, I mean, whatever you catch comes out of there. If you catch a 5, if you catch a 25, if you catch, no, it's not a 3 in this one. So we start with a 5. For sure, they're both divisible by 5. 75 divided by 5, and do you remember how to do that, right? So we go 75 divided by 5. 5 goes into 75 one time. 5, subtract, get a 2, right? So bring down the 5, and we get 5 more times. So that's 15. And 20 divided by 5 is exactly, I'm sorry, I gave it away, didn't I? 100 divided by 5 is 20. Still got a 5 in common. And so 15 divided by 5 is 3, and 20 divided by 5 is 4. 3/4. Look at that. It's a fraction at the bottom. So 1 and 3/4. So 1.75 is really 1 and 3/4 in disguise. Okay, last ones. We're going to practice putting them in order. So rational numbers in order. That means I'm going to mix fractions and decimals and whole numbers all together, and you're going to put them in order. So I think the easiest way to do this, now again, you can do it the other way if you want to turn them all into fractions, but I think it's easier to turn them into decimals. Because if you turn them into fractions, you would have to go back and have common denominators, and I know you all love that, right? Okay, so turn them all into decimals. 1/4, we divide it out, 1 divided by 4, that's really 0.25. And again, we do 1 divided by 4 like we just practiced. We have negative 3/5 as a decimal. So convert that here, and so if we want to, it's going to be a negative number, by the way. Don't forget that. You don't want to lose the negative there. That is going to be negative 0.6, right? And so again, if you don't believe me, divide it out. 3 divided by 5. So I've got over here, I've got 0.25, 0.2, right? Negative 0.2, negative 0.6, and 1.1. So I don't think anybody would argue the fact that the biggest number is for sure out of these 1.1, right? It's more than 1, and it's not negative. All the others are fractions. So 1.1 is the biggest number here. Then I've got to compare the other ones. So let's see here. 0.25 is positive, right? This is positive, so it's bigger than any negative. So that's got to be the next one down if we're going backwards, right? So, and I do want you to rewrite those in the original form I gave you, just like we practiced before. Now I got to figure out which is bigger, negative 0.6 or negative 6/10, right? Negative 0.2. Well, now if they were regular numbers, 0.6 would be bigger, but it is a negative, so you must think backwards. So negative 0.2, and then negative 0.6, but remember, I want to see it in the original form I gave it to you. So there we have, smallest to biggest. We have negative 3/5, negative 0.2, 1/4, and 1.1. Don't worry, you're going to get to practice this really soon. Also, don't forget, if you don't remember how to do one of these skills, because I just kind of gave you 3 things when you're working the practice problems, feel free to go back to this video, pause, rewind, whatever, to get that part figured out. Alrighty.